Welcome back for another deep dive. Today we're going to be exploring something really fascinating. Um, it's this whole world of AI that can write its own code.
AI writing code.
Yeah. Not just any code, though.
Whoa.
It's code that could totally revolutionize the way we use GPUs for machine learning.
Okay, I'm intrigued. Like how?
So imagine AI that can take, say, PyTorch code and turn it into those super efficient CUDA kernels that GPUs need. It's like giving AI the keys to the kingdom of GPU performance.
That sounds, yeah, that's huge. I mean, CDA is not exactly easy to write, even for us humans. So how does AI even start tackling that?
Oh, that's exactly what we're going to be diving into today. And our guide for this deep dive is a research paper. It's called The AI Pseudo Engineer, Agentic Pseudo Kernel Discovery, Optimization, and Composition. Bit of a mouthful, but the paper itself is really insightful.
Okay, the AI pseudo engineer.
Yeah.
I like it. So who are the brains behind this research?
It's by Robert Charcot-Lange and his colleagues. And, one of the first things they point out is this insatiable demand for compute power in machine learning. It's like a constant hunger.
Yeah, for sure. Models are getting more and more complex and the data sets are just exploding.
Exactly. The paper actually cites research showing that compute requirements for the top AI models have been doubling every few months since 2012.
Wow, that's crazy.
And that's way faster than the improvements predicted by Moore's law. So the question is, how do we bridge that gap? How do we keep up with this demand for computational power?
Well, it sounds like this AI CUD engineer might be the answer.
Yeah, and that's what's so cool about this whole thing. It's not just building models anymore. It's about optimizing the hardware that runs those models.
Okay, so it's like having an AI engineer working behind the scenes, constantly fine-tuning everything to make sure the code runs as smoothly as possible on GPUs.
That's it. And they do this through a really clever combination of, get this, large language models, those LLMs everyone's been talking about, and something called an evolutionary optimization process.
So it's like a blend of language understanding and this like survival of the fittest approach to code.
Exactly. And this AI CUDA engineer, it works in 4 key stages.
4 stages. Okay, walk me through it. What's the first step?
Well, first things first, it takes the PyTorch code, right?
Right.
And converts it into a more functional format.
So it simplifies it.
Yeah, exactly. It's like translating from a language that humans understand into something the AI can work with more efficiently.
Makes sense. Then what?
Then, in stage 2, the AI takes this simplified code and translates it into CUDA, which is, the language that GPUs actually understand.
Wow, that's going to be a pretty complex translation. Like I said before, CUDA is not exactly a walk in the park.
No, it's definitely not.
Okay.
But that's where the AI's real expertise comes in.
Yeah.
It's able to handle all the intricacies of CUDA and produce code that is really, really efficient.
So it's not just translating, it's actually making the code better in the process.
Yes. And then, of course, comes the optimization stage, right?
Stage 3, right. What happens there?
So in stage 3, the AI doesn't just stop at a working CUDA kernel. It actually starts to experiment, like it tinkers with the code.
So it's trying to find the best possible version of that code.
Yeah. It's running all these mini experiments, trying out different variations, and seeing which ones run the fastest on a GPU.
So it's like it has this internal competition going on. Only the fastest code survives.
Yeah, it's an evolutionary process. Survival of the fittest, but for code.
That's a great way to put it. So what about the last stage, stage 4? What happens there?
This is where it gets really interesting. The system starts to learn from its own experience. They call it stepping stone composition.
Stepping stone composition. What does that mean?
Well, basically, it builds on a library of previously generated kernels. It's like it's building its own knowledge base of what works and what doesn't.
Ah, I see. So the more it works, the smarter it gets, and the better it gets at optimizing this code.
Exactly. It's like giving a human engineer access to a massive database of code examples and best practices. Now, to really understand what this AI CAD engineer can do, the researchers put it to the test using something called kernel bench.
Kernel bench. That rings a bell.
Yeah, you might remember it from our deep dive on code optimization a while back.
I think so, yeah. Remind me, what is kernel bench again? Oh, yeah, right. Isn't it like a big collection of CUDA kernels that are used to test how well a system can optimize code for GPUs?
That's exactly it. It's like a proving ground for the AI CD engineer, to see how well it can handle real-world challenges.
Okay, so they basically threw a bunch of tough CUDA problems at this AI and said, go for it.
Pretty much. And the results were pretty amazing. First off, the AI was able to correctly translate over 91% of those 250 kernels.
91%? That's seriously impressive considering how tricky CUDA can be.
Right. And it's not just translating little bits of code here and there. We're talking about complex kernels that are used all the time in machine learning.
So this thing's not messing around. But how well did the AI's code actually run? I mean, in terms of performance.
Well, that's the really exciting part. The AI didn't just translate the code, it actually made it run faster. And not just a little bit faster either.
Oh, you're going to have to give me some details here. How much faster are we talking?
Well, in a lot of cases, the AI's code actually outperformed hand-optimized code written by human experts.
Wait, are you serious? The AI beat human programmers.
It did. In some cases, it was way faster. Like, for one task called Conv 3D Group Normine, the AI achieved a speed up of over 112x.
112x. That's mind-blowing. I mean, what are the implications of that kind of speed increase, like for researchers working with massive data sets?
It could completely change the game. Imagine being able to train a huge model in hours instead of weeks. It could lead to some incredible breakthroughs.
No, yeah, absolutely. Think about fields like medicine or climate modeling, problems that need a ton of computing power. They could be solved so much faster with this kind of optimization.
It's not just about speed either. It's about unlocking new possibilities that we couldn't even dream of before.
It's like pushing the boundaries of what's possible.
Exactly. And it gets even more exciting when you see how the AI tackled a real-world challenge. They gave it ResNet 18.
ResNet 18, the neural network for image recognition.
The one and only. And guess what? The AI was able to translate the entire architecture into CUDA code.
The whole thing.
Yep. That's a big deal because before this, most attempts focused on just small pieces of code.
Yeah.
But this AI showed that it can handle the complexity of an entire real-world model.
Wow, that's really something. So this AI could potentially optimize the code for an entire machine learning system, not just individual parts of it.
That's what it looks like. And the researchers actually took it even further. They incorporated something called retrieval augmented generation, or RAG.
RAG, what's that all about?
Well, basically, RAG gives the AI access to a massive library of, you guessed it, CUDA kernels.
Okay, so it's like giving the AI a textbook of optimized CUDA code.
Exactly. The AI can learn from its past successes and use that knowledge to tackle new challenges even better.
That's brilliant. The more it learns, the better it gets. And of course, the code gets faster too.
Right. And the results with RAG were fantastic. The AI achieved even higher translation success rates and even bigger speed improvements.
That makes sense. Like, the more experience it has, the better it becomes at its job. So did the researchers keep all this amazing code to themselves, or did they share it with the world?
They did something awesome. They created something called the AI CUDA Engineer Archive. It's a data set of over 30,000 CUDA kernels generated by this AI system, and it's completely open source.
Whoa, 30,000. That's a massive library of code. What could people do with that?
It's a huge opportunity. Imagine researchers, developers, even students being able to access all this optimized CUDA code. It could really level the playing field in terms of who has access to high-performance computing.
Yeah, that's a really important point. It democratizes access to these powerful tools, which could lead to some amazing innovation down the line.
Exactly. And it's not just about providing ready-to-use code. This archive can also be used to train future AI models that are specifically designed for generating CUDA code.
So it's like a gift that keeps on giving.
Exactly. This could spark a whole new generation of AI tools built on this open source foundation. Now, we've talked a lot about the technical details, but I think it's important to step back for a second and think about the bigger picture here.
Okay, yeah. Zoom out a bit. What are the key takeaways, you think?
Well, one of the biggest takeaways for me is that AI is no longer just about building models. It's about optimizing the entire system, right down to the hardware.
It's becoming more aware of its own environment.
Right, and this could have huge implications for the future of AI development.
I mean, we've always been somewhat limited by the hardware available, by how much computing power we can access. But this AI UDA engineer, it suggests that we might be able to overcome those limitations, at least to some extent.
We can start pushing the boundaries of what's possible with the hardware we already have.
And that's a really exciting prospect. It could lead to a whole new wave of innovation in AI, especially in areas like training large language models.
Exactly. And it all starts with optimizing the code, making sure every line is as efficient as it can be.
Yeah, it's all about squeezing every ounce of performance out of the system.
Okay, we covered a lot of ground here, from the nitty-gritty details of code optimization to these broader implications for the future of AI. But before we wrap up, I have to ask you one more question. We keep talking about this AI as an engineer, like a CUDA engineer.
Right.
But it feels like it's becoming something, well, something more. Like, could we actually see a future where AI isn't just optimizing code, but actually designing entire machine learning systems from scratch?
That's a really interesting thought. I mean, we've already seen this AI Hysdia engineer optimize some pretty complex architectures, like that ResNet 18 we talked about.
Yeah.
So yeah, I think it's definitely within the realm of possibility. Imagine an AI that could design those architectures itself, like tailored to specific tasks and even to the specific hardware they're going to be running on.
So instead of humans having to handcraft these systems, we could have AI doing the heavy lifting, optimizing both the algorithms and the hardware.
Exactly. It would completely change how we develop AI. And who knows what kind of amazing solutions we could come up with, things that we as humans, might never even think
It's
of.
like AI could become this true collaborator in scientific discovery, helping us push the boundaries of what's possible.
I think you're right. It's definitely a future worth exploring.
And it really highlights something important about this whole deep dive.
What's that?
This AI CUDA engineer. It's not just about making code run faster. It's about expanding the potential of AI itself.
Making it more powerful, more accessible.
Exactly. And it feels like we're just at the beginning of this whole new era in computing, where AI is playing a much more active role, driving innovation in ways we never thought possible.
It's an exciting time to be working in this field, that's for sure. So much potential still to be unlocked.
Well, thank you so much for taking us on this deep dive. Our listener has a lot to think about now.
It's been a pleasure. Always happy to chat about AI and the amazing things it can do.
And to our listener, we hope this has sparked your curiosity about the future of AI. Until next time, keep exploring, keep learning, and keep diving deep.